All right, so we've seen that we can use the law of sines anytime we have an angle opposite side relationship in a non-right triangle. So today we're going to look at some applications and see how we can use the law of sines to solve for missing side lengths or angle measures, depending on what the question is asking you to find. In our first example, we have a pilot who began a flight traveling 80 miles northwest. So this is the starting point, and then they showed us in this northwest path that they flew 80 miles. And then to avoid a storm, he made a turn and then turned back to his original location. So this was the path that they've drawn the diagram for us. We want to find the total distance of the flight. So we already know it took 80 miles to travel here, and then it flew this distance when it took its turn, and then flew that distance to return back to its starting point. Now we can see that we have a non-right triangle, and in this problem right here, I have this 15-degree angle, but I do not know the side length opposite it. I have this 108-degree angle, but I do not know the side opposite that. And we know that in order to use law of sines, we always need an angle opposite side pair. So this is the only side length we know. So we would need to know that opposite angle in order for us to use this law of sines. But the good news is we know that a triangle adds up to 180 degrees. So we can find this missing angle by taking 180 minus 108 and then subtracting 15 from that. And we'll find out that missing angle right here is 57 degrees. So now we have our angle opposite side relationship, and we can solve for x and y now using the law of sines. So I'm going to always put my unknown on top of my first fraction. So let's say we want to find x first. I'm going to put x in my numerator and then divide it by the sine of its opposite angle, which was 15 degrees. And then I'm going to set it equal to that angle opposite side pair that we actually have values for. So the side length of 80 and then the opposite angle of 57 degrees. So 80 divided by that sine of 57 degrees. Again, the reason I like setting it up like this is now I can easily solve for x by multiplying both sides by that sine of 15 degrees. And then I can just grab my calculator and make sure I am in degree mode and type in 80 divided by sine of 57 degrees and then multiply that by sine of 15. And I found out that that length was about 24.7 miles. Okay, so now if I want the total distance of the flight, I also need to find that value for y. So once again, I'm going to use the law of sines to find that missing length. I'm going to find y divided by the sine of its opposite angle, which was 108 degrees. And then again, I'm going to use that given angle opposite side relationship. So 80 divided by that sine of 57. And again, I can quickly solve for y by multiplying both sides by that sine of 108 degrees. And even though this angle is obtuse, it is a quadrant 2 angle, and we know that sine ratios are positive in quadrant 2, so this is still going to give me a positive value here. So I would just do 80 divided by sine of 57 degrees, multiply that by sine of 108, and I got that length to be about 90.7 miles. And then if I want the total distance, I would just add up all three sides. So I would take the 80 plus that 24.7 and then that 90.7, and I would find out my total is about 195.4 miles. All right, now that one wasn't so bad because we did have the diagram. In our second problem, we're going to create our own oblique triangle, drawing it ourselves, and we're going to bring back our good old friend bearing. And again, we have our directional bearings here to help us out. So as I'm drawing these out, I'm going to make sure that I'm drawing my little direction compasses at each point, and then paying attention to whether I'm moving northeast, northwest, southeast, or southwest. So in our second example, we're going to draw our own picture. We're looking for a fire that's sighted from ranger stations A and B. The bearing of the fire from station A is 35 degrees east of north. So east of north means that I'm going to go and head towards the right of station A. So I'm going to draw my point A randomly on my paper. 35 degrees east of north, I'm going to draw my north line and rotate 35 degrees towards the east. And then my fire was spot somewhere on that path. And then the bearing of the fire from station B is 49 degrees west of north. And I also know that station A is 1.3 miles due west of station B. So I do know that A and B, based off that last sentence, are on an east-west line, straight across from each other, 1.3 miles apart. And so here I'm going to draw my compass at B, and we're going to go 49 degrees west of north. So I'm going to draw my north line at B, rotate 49 degrees towards the west, and so my fire is somewhere up here. All right, if I were artistic, I would draw a cool fire there. All right, so here's my diagram. So what I'm going to do is figure out how far is the fire station, or how far is the fire from each ranger station. So I want to find the distance from station A to the fire, and I want to find the distance from station B to the fire. So I'm going to label those X and Y. And again, right now this isn't very promising because I have these two angles that are outside, but because this is a north-south line, and this one is 2, and this is an east-west line, I know these are right angles. So I can get the two angles inside by subtracting from 90. So I can take 90 minus 35 and find out this angle right here is 55 degrees. 90 minus 49, that angle right there is 41 degrees. And then to find the angle up where the fire is, I can add those up and then subtract them from 180, and I'll find out this angle up here is 84 degrees. Once I do that, now I can see in this diagram, and if it helps you to redraw it without all the extra stuff, feel free to do that. We've got A, B, 84, X, Y, 1.3, 55, and 41. So here's that angle opposite side relationship that we always want. So that's how I know I can use my law of sines. And if I want to find X first, I would put X divided by sine of 41 degrees. Set that equal to the length of 1.3 divided by sine of 84. Multiply both sides by that sine of 41 to get the X by itself. And I would find out that that length was about 0.86 miles. If I want to find Y is opposite that 55-degree angle, so I would put Y divided by sine of 55 degrees. Set that equal to 1.3 divided by sine of 84 for that angle opposite side pair. Multiply both sides by sine of 55 to clear that fraction. And if I do that math, then I would find out that Y is about 1.07 miles. So the question they wanted me to do is figure out how far is the fire from each ranger station. So now I can answer it. The fire is 0.86 miles. That was my side length X, so that was from station A. And then Y is how far it was for the fire to station B. And so Y was 1.07 miles from station B. So that is how we use the law of sines to solve some application problems. If we have to draw our own bearings. Again, make sure you're drawing your points. Read the question to figure out if the stations are east and west. Sometimes they are north and south. And then when you know they're east and west on that straight line and you have those north-south lines, then you know you're getting these right angles. So we can use those complements and then the triangle sum to find that third angle in there. All right. If you have any questions, let me know.